Alright, we were having some queries with regard to the topic on sampling methods, and now the second question we'd like to clarify is whether systematic sampling is a form of random sample. Now, could we provide more elaboration on why systematic sampling is a form of random sample? Now, to answer this question again, let us recapitulate what is meant by a random sample. A random sample or sample is random if and only if every member of the underlying population of interest has an equal chance of being selected as part of this sample. So we need every member to have an equal chance to be in the sample. Now, referring back to our notes on systematic sampling, it's a method in which elements in the sampling frame are first arranged in some order, right, with some starting point being randomly chosen in the sampling frame, then items are picked at regular intervals. Now in the example, maybe we'll make use of this example to illustrate why systematic sampling would produce a random sample in which every member of the population has an equal chance of being selected. Now consider 120 households in an estate, and we would like to award to 8 households randomly a prize. And as such, these households has to be listed in order, and we're going to pick 8 households, which means every household would be picked, and a random starting point is chosen. Now, to illustrate this more clearly, let us take a look again, right? Our population is 120 households in an estate, and we need 8 households to be picked up. And therefore, we are going to number them off. Household number 1, 2, household number 3, household number 4, household number 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, and so on and so forth. And eventually, if we just do that, we would have 120 households altogether. And now we're going to pick a starting point, right? Now, because we have 120 households altogether and we need only 8 households, so these 120 households are broken into 8 rows of 15 each. And we're going to pick a random starting point, i.e. we're going to choose what is the procedure of systematic sampling in this example. We're going to choose a random starting point, i.e. a household that is numbered 1 to 15 as part of the sample. That's the first step of the procedure in this systematic sampling. And in the second step of the procedure, we are going to pick out every 15th household after the starting point until a total of 8 households are selected. Now, coming back to this illustration, suppose we want a sample via this systematic sampling method, and we would choose a random starting point. It could be 7, right, as is suggested in this example. Then the next household that would be picked out would be 15th after 7, so we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That turns out to be 22. And we jump another 15, that goes to 37, and so on and so forth. So eventually we end up with picking out these households, right, from 7, household number 7, household number 22, 37, and so on and so forth, up to 112. We pick, right, all these households, at an interval of 15 until a total of 8 households are selected. Now, how do we verify that we do indeed have a random sample? Is this sample that is selected using the systematic sampling method a random one? One might ask. And to satisfy ourselves that this is indeed a random sample, we would have to look at whether the probability that each household is selected has an equal chance. What is a probability that is associated with the selection of each household? Now, let us just consider, right? What happens if we try to select the second household? What is the probability that is associated with its selection? Of course, when we choose our initial starting point, right? Where was our initial starting point? Okay, our initial starting point had to do with the first 15 households, am I right? Look at our procedure again. Okay, first 15 households. Okay, and if this random starting point is being chosen now, the keyword here is still being random. Okay, that means each of these first 15 households had an equal chance of being selected, and as a result of which, what is the probability that is associated with the selection of the second household? That would be 1 out of 15. Okay, and therefore fill in the answer. That is 1 out of 15. 1 out of 15. Okay, and what about the probability that is associated with the selection of the 8th household? Again, household number 8 appears in the first row, as we can see, and the probability that is associated with its selection would also be 1 out of 15. Now, if we are going to explore what is the probability that is associated with the selection of subsequent households, such as household number 2, okay, or household number 17, I'm sorry, okay, that is no longer in the first row, but what happens is, when would we be able to select household number 17? As illustrated here. Okay, household number 17 will be selected if and only if the household that is 15 positions before household number 17 is selected, and which household is that? That would be household number 2. Okay, if household number 2 is selected, then household number 17 is selected, and conversely, if household number 17 is selected, household number 2 has to be selected in the first place for household 17 to be selected, and therefore the probability with which household 17 is selected is the same as the probability that is associated with the selection of household number 2. Turns out to be 1 out of 15. Okay, notice some pattern over here, and we might just continue this same argument with others. For example, what is the probability with which household number 98 is selected? Okay, let us take a look at this diagram again. Okay, now household number 98 is selected if and only if the household 15 positions before is selected as 83. Okay, and now this household that I'm pointing to now is selected if and only if household number 68 is selected, because that is just 15 positions before household 83, and so on and so forth. And therefore it turns out that the probability that household number 98 is selected, okay, is equals to the probability that this household is selected 83, and is equals to the probability that this household is selected, is equals to the probability that this household is selected. Now, if and only if, for example, household number 8 is selected. Okay, now household number 98 is selected if and only if household number 8 is selected. We call that the procedure. Okay, what is the relevant procedure? The procedure that every 15th household is selected after the starting point. So we see this yellow column over here. Okay, household number 98 is selected if and only if household number 8 is selected, and that turns out to be 1 out of 15 as well. Okay, and what is the probability with which household number 102 is selected? If we go through the same argument, okay, that will take us back to the probability with which household number 12 is selected, which turns out to be 1 out of 15 again. Okay, and in general, okay, if we apply this argument throughout, we see that all the households, right, the probability of any household being selected is equal to the probability of the corresponding household in the first row being selected. For 102, that's 12, okay, and therefore it is 1 over 15, and for X, household number X, that would be also 1 over 15. And since every household has the same probability of being selected, this would mean that the sample that is selected, the sample of 8 households that is selected, is indeed a random one. Okay, this is because every household has an equal chance to be